Alright, hello and welcome back. I have some very lovely ramen and going to be working through this project that we've been working on. So doing image recognition if you're not cut up speed. I wouldn't actually call it image recognition, but basically we're trying to identify the text and get it at a high accuracy to actually detect text. So now that I remember this, I did want to try one thing, and if we go down here to this Kaggle thing, so we're going to pull up a random data set about football. I don't want that necessarily. But basically Kaggle has a bunch of data sets that are completely open for everybody to use. So I'm just going to see if there's anything for text. And see if there's a data set that has already labeled images with text, because that would be actually really cool. Alright, so I can't find anything on this. There's obviously like the MNIST data set that deals with handwritten characters. Might be an avenue that we go down later in the future, but it sort of doesn't make sense. We're probably going to want to keep on working on our contour stuff that we were working on last episode. So I was messing around with this code, and so if I run this, it will pull up each image. And this is our image 2, so this is what the fine contours actually comes up with, I think. Which, it doesn't really look like contours necessarily. So this is where we're at. I mean, if there's good contrast, we're actually doing pretty good at getting the text really broken out. But see, like this is just like messed up. I also changed this from Thresh by or from some other setting. So I think I just want to do some more researching on basically what we're going to find in terms of settings for CV2, and getting the text more contracted, I guess. I think a binary classification will sort of work here, because obviously this is not going to be like perfect, but if we zoom in on the picture, right? You can see there are very clear, distinct lines for the text. And the other thing is, our text, at least for our purposes right now, is going to be the same exact color. So we have the same pixel value, because obviously letters are added in post-processing software, so in like a Photoshop. So they're going to have pretty predictable contours, and they're going to be the same color. So if we can just find that one color, then basically we can just try to isolate that. And if anything isn't more than like 5 pixels out, you know, the same color, because obviously lower resolution, we're going to have it to where like, you know, we don't want to go more than a few pixels out away from what we have. But you can see very, very distinct lines in the picture. Enhancing. Alright. So I'm going to see like how to find one color CV2. Alright, so this inRange function will take in the image and then lower and upper bounds, so that we can define, hey, we want this color. So this is the cool thing. That's actually awesome, because here's the thing. We're going to have an image like this, right? That's going to have white text, or an image like this where it's going to have black text. So I think you just sort of try to go to those extremes. Otherwise, have to find other methods. But for our ideas, that's what we want to do. So before we even process this image into gray, let's create these MP arrays. I'm just going to copy this. So we'll pass in the image here and change that into a different color format. So I believe that this is going to find blue colored objects. So that's pretty cool. So I actually just want to see what is created here. Just go ahead and copy this over here. I'm just going to comment all these guys out for the time being. I have to also comment out this line. So we just want to show our HSV But actually we need to set new thing. So we're gonna create this mask here. That works, and then I think he just prints out the mask actually. I'm just going to copy that part too. So all we have to do for this is instead of frame, just put in IM, and let's just try printing this out. I have no idea what this image is. Alright, I gotta, it's going by too fast. I'm just going to set this equal to 20,000 seconds, or 20,000 milliseconds. That'd be a long time. So we just get a lot of things coming up. So that's our original picture. This is the mask. That's the res. And see, so we're detecting blue here. I have no idea what this is supposed to be. Oh, that's just the image. So I'm printing out another thing that I do not need to. So this is our result, I guess. Basically, it's just saying it's doing a bitwise operation. So if it is equal to the mask, which is going to be our blue ranges that we defined, then it's going to pull that out. And it's pretty awesome because obviously that's working. I'm also going to use these wait keys so that way. Oh boy. Yeah, no. That was a little bit too much. Alright, that unfortunately didn't work. Alright, so I'm going to set this so that way we see everything for 5 seconds. And just get the basic idea. And I also don't even want to grab the mask either for right now. So that way we can just see the original picture in the frame. So obviously not much blue here. That actually looks pretty cool. So we're not really doing much here. Alright, so there wasn't much to see there because we don't have very many pictures with blue things. So I sort of need to wrap my mind around this. So let's just see if we can do 0, 0, 0, which I'm a web dev. I should know this. Alright, so 0, 0, 0 is black. And then we'll just keep on using this, I guess. I don't know what that is. And RGB color picker. Alright, so 0, 0, we have to actually just go up on the axis. So let's go 12, 12, 12. Hopefully this will show anything that is pretty much pure black. I think. Okay, so this Don't Regret Fun picture, which is 1619. We actually do have a color picker, thankfully. Oh, apparently not. I have no idea how this works. There we go. So thankfully, not to complicate things, this is 0, 0, 0. Now if you look closely, this image has some pixels that actually aren't totally black. So we actually chose a higher bound. So these pixels that are a little bit brighter are 888. So for the time being, I want to just move out every image besides those with black text. We'll keep those, keep that. Awesome. Let's move that out of the folder so that way we just have a good, nice little testing set here. We're going to do that, and then let's just run this again, see what we're actually expecting. Fortunately, this image has the text on it, so that almost worked actually. Oh. Well, I accidentally put that 122, so let's see. I want to see that. Boom, that's awesome. So none of the rest have worked, but that one did. Alright, I'm going to do a little bit of research on this because I do not understand this upper and lower bound, obviously, since we're not pulling out correct values. Because like 12, 12, 12 should be enough to get the contours I want. You know, like not those images, but like this is pure black. We just looked at this one. This one we're basing it off of, so it makes no sense why this is coming back like this. So to research land I go. Oh, you know what I want to do real quick though? I want to print out the HSV. I want to see what this image looks like. Whoa. Okay, so this is why it's not working. Oh man, this thing made the image look so weird. Whoa, okay. Well, at least I understand why this isn't working. So hopefully I didn't have to do that pre-processing step and I can just pass in image, because if so, we're in the money. So I think that technically is working. That part isn't showing much. Interesting. So this is a pretty cool article that I came across. They're trying to use a thing that will detect the colors in a Rubik's Cube. So their first step was converting this to RGB values. That's actually pretty neat. I think this is pretty cool. Because I guess if you apply the combination, you know, if it's red, then it shows up pretty much white, and it will show up darker on the other ones. I'm not sure exactly how that works. So this is a different kind of color space instead of RGB. And what it does is the first channel right here is the lightness, the luminosity, and then A is green to magenta color, and then B is blue to yellow color. I always sort of want to just try this out, you know? Just see what's going on here. I'm just going to use this HSV, since that is not going to produce what we want, and just copy this color. So we're using HSV. I'm not sure what that is. Possibly like hue. And then let's print out our image. Interesting. Whoa, wow. That contrast is amazing right there. Huh. That's pretty neat. Yeah, so this was the other color space so we're using that was like, looked really weird. It's HSV. Alright, this actually has a lot of good info, so I'm going to try using this guy. We're adding a lot of code here, but just gotta experiment and see what works. So I don't know what bright, I think bright, probably going to be our image. Yeah. Because right now we're using in range above here and we're using our image, so yes. Anywhere that there's bright, we would like to switch this to image. I'm also going to modify these MP arrays, so instead of subtracting from the threshold, I'm just going to make the 0, 0, 0, because that's fully black. And then we'll have a threshold of, I think I'll change this just to 20. Alright, so I just updated the image names, and I'm going to stop showing this stuff for a hot minute. And then we're going to show these and just add a wait key down here so that we can actually see the results. So we're not really getting much. Alright, so I'm going to increase the threshold and see if that helps. Increasing it up to 50. So the only one that seems to be working is this guy. Alright, so that didn't work. I think I just want to look more into in range. Alright, so the Stack Overflow, that has the answer. So I'm actually just going to get rid of all this code. Quite a lot. Alright, there we go. So we already did this. We'll see if this helps, but basically they just recommended changing that, and what we're going to do is we have our lower bound, which we're just going to keep these. Oh, and so he set the upper bound to 255. Maybe I was misunderstanding how this thing works. Maybe it's get rid of everything that's not within that boundary. Oh yeah, because it said that. If all of your image you want to are roughly like the ones you provided, where the actual design consists of gray colors and the text is always black, I would first white out all content that is not black or already white. Doing so will leave black text left. So you know what was happening? I was saying, okay, we'll choose everything that's in this small bound, right? We want to actually remove that from our bound. So hopefully that will work. Cool. All right, we'll try that. Okay, let's not do this HSV. I don't like this. I'll keep it, but I'm going to pass in... Oh, I am already passing in, I am. Oh, but I am printing out. It's the same thing. I'm so confused. What am I missing here? So it's saying 00255. That's not working. So that's just for tracking white color. So this is supposed to detect just white color, so I added in this image. I don't know what is going on. Alright, I think I want to look at HSV more because it seems to be what people recommend for this. It just looks really weird. And I also want to 100% make sure that I'm not making any errors. I don't need the mask. Oh. Okay, this could have been why it wasn't working. So I was passing in HSV here. We need to pass in the original image and then we apply the mask that the HSV provides. So, whoa. So I don't think we care about the HSV. I think we care about the res. So yeah, I think what we really want is the res. So I'm just going to print the original image still. There we go. All right. Nice. So we're trying to find pure white. So this isn't going to do anything. So that didn't work. That's so weird. Alright, so we changed what we're using here and we have sensitivity. So we're just going to try... I mean, I honestly want to detect this with a light. I want to start detecting the black. So we have a little sensitivity here so that way it doesn't have to be fully thing. So this is what I wanted. There's no way to pause, unfortunately. But you can see that we're actually getting all the white. And I believe, even though that looks like it's getting the black, it's actually just getting all the pure white. So we were actually getting this. So if we increase the sensitivity just a tad, go up a little bit more, this is getting better, a little bit more accurate. It's detecting more of this. And perfect. Okay, that's what we wanted. So you can see, I'm actually just going to move all these images out. Alright, so this is great because this is something that necessarily doesn't have the best contrast, right? Like, it could be worse, but it's getting the text very well, and it's only getting, like, nonsensical objects, too. So that's great because here's what we can do. What we can say is that we can, one, get the area of the text, and then this also helps OCR recognize the letters too because there's less noise in the actual image. So that's actually looking pretty good. And we can also say, like, we did this for both white and black text, right? But we'd say basically, okay, what's the area of the text to image? And then we can classify that image as well. That's awesome. All right, so now that we have that, I think if we did this, so I want to copy these lines, and here's what we're going to do. We're going to change this to lower black and then upper black. And I believe if we turn this to 0 and then say plus sensitivity and then change these guys to 0, let's just try this out. lower, or this is going to be upper black. Let's just see. Okay, that makes sense. There's pretty much no black in this, although I feel like I probably... That's the one that we want. We're going to move this image back in. Might as well move this image out for the time being. So that way we can just mess around with this image that has a pretty good amount of black text. Alright, so I'm not doing this right. I don't understand how the RGB values are working here. Oh, okay, so if we think about this for a second, right? Let's print out HSV. This is our text, which is actually pretty wonky. I'm not sure, like this doesn't look right, because compared to our original image, this text is almost completely black, but then it starts changing. Yeah, like this is not helping out. This is making everything look really strange. Although that is only one part, so I'm going to actually try the image. Just pass that in. This may not be the best example because this isn't like pure black. I think I'm sort of on the right track right now because the more I increase the sensitivity, the more it's starting to cancel out some stuff. So I just need to work on getting this working perfectly. Alright, so quite literally the strangest thing happened to me. As I was running the program halfway through, my mic just cut out. OBS muted my mic for some reason. Thankfully I'm in a very good mood because I had a good time actually coding, so I guess I'm going to step back through exactly what I did. So this is where I was at. I wasn't even using the Numpy arrays. Oh man, that's such a shame. I had such a good amount of progress that was being made. But basically, I need to turn on music once again. That is so unfortunate that my mic got muted. I have to check. I'm going to be so worried about that now. But basically, I was doing some internet researching, and I found this MP Wheres. So what this does is it targets individual pixel values. This converts the image into a Numpy array. And so I basically just use a logical AND that says if the image pixel value is between pure black and a little bit of a black with the spice, like not completely black, then we change it to a red color. So let me go ahead and I'm going to move every image that's not this one out so I can show you exactly what we're doing here. So what we're doing is we're going to convert every black pixel within this range of 0 to 20. We're going to convert that into a red pixel. So look at this. So it's targeting the black, and it's awesome. Like, it really works well. So then what I do is after I've converted that text into this, you know, nasty red, but it's a way to differentiate from the rest of the picture, I target everything that is above this value. So anything that's not the black text, I convert it into pure white. So let's go ahead and look at this. So now we just have the red text with a little bit of noise, but it's pretty filtered out. So we filter out all the rest of the stuff, and then we go back here and we target basically every pixel that is red, which is our text that we targeted before, and we change that back into black. So here's what we're doing here. So we're saying don't regret fun. So now that's pure black. And there's a little bit of noise, but that way we just made a huge contrast difference in the image. And so if you see now, it's actually picking this up perfectly. That's amazing. That's great. And then I also added a single tick mark, which you have to do 2 backspaces to use. But basically, that's all I did. So I tested this out with some other images. It's not working exactly perfect, which I don't think it ever can unless you implement some machine learning. Because, like, not necessarily with this image, but if we get Like, you'll just have text that will not be standard. But the idea is that if these are memes, which I need to pull in, if these are memes, right, they should have a very standard font. Actually, just look this up. Meme font. I mean, apparently Vox made an entire article on why every meme uses this font, so, it's perfect. So, that's actually really great for what we're trying to do, because then that means we're targeting one thing, and it's a pretty standard font, so it's easy to read and hopefully easy for PyTestRec to pick up. So, I'm very sad that my microphone got muted. That is the most disappointing thing ever. But look at this, like, it's great. And this was the other one that I want to show you. So again, getting the very nice little contrast. And we're still having some problems and missing a few characters, but it's so close. Like, it does this entire 2-line sentence right. It's missing one letter here, and it's messing up a couple letters here, but that's pretty accurate. So we can keep on refining this process. And basically what I said for next time, what I want to do is add the ability to detect white text, and then do PyTestRect on both the white and black text. If it's not able to find text in one or the other, then it should be able to find text in one or the other. Otherwise, we just don't have text within that range. We're not going to worry about it. So we're going to assume that either text is all white or all black, and based off of that, we can find the area of text to image, so that way we can sort of classify it a little bit, and we can just do more things with it. So I'm going to do that next time. So heartbroken that it didn't record properly, but as a short little recap of what I did. I will push this code up to my GitHub repository so you can check it out. I will leave that link down in the description below if you want to go look at that. And I'll see you next time. Thanks for watching.